Hello and welcome to my YouTube channel. In this video, I am going to explain how to draw a shear force and bending moment diagram of an overhanging beam with UDL partially acting on the beam. As you can see in a diagram, we have two UDLs but in a different shape. Okay, we have three steps to follow: reactions, shear force diagram, and then bending moment diagram. First of all, we will calculate reactions. Okay, so how we do that? Total load is equal to 2 multiplied by 1 plus 2 multiplied by 1. As you can see, we have 2 kilonewton per meter here and 2 kilonewton per meter at the other end, overhanging part. So 2 multiplied by 1 meter, 2 multiplied by 1 meter, all together we will get 4 kilonewton. Okay, so this is going to be RA plus RB is equal to 4 kilonewton. Okay, now we need to calculate at RA and at RB individually. Okay, how we do that? RB multiplied by 3, so RB multiplied by 3, 1, 2, 3 meters equals to 2 multiplied by 1 multiplied by 1.5 plus 2 multiplied by 1 multiplied by 3.5. Okay, so 2 is our load, multiplied by 1 because acting on 1 meter, multiplied by 1.5. So UDL always acts at the middle of its span. So 0.5 from here and 1 from here to get to point A. So that's why 2 multiplied by 1 multiplied by 1.5. Then the next one we have UDL at from B to C, which is 2 multiplied by 1, which is a load, multiplied by 3.5. So half distance from here and we have 3 meters from here. So 3.5 is here. So now it will be altogether 3 plus 7 equals to 10. So we have reactions at RB is equal to 10 divided by 3, which is 3.3 kilonewton. Now reaction at RA, which is total load minus RB. Total load we have calculated 4 kilonewton minus 3.3, we will get 0.7 kilonewton at RA. Okay, now based on these numbers we can draw our shear force diagram. Okay, so we have one point here, this is point C, this is point B, but we also have 2 points in the middle as well. I mean, you can give it any name, E and D. Now at point A, we have reaction at RA 0.7, which is going to go upward here somewhere. Okay, so this is 0.7. Now we have to go to point E and D because between E and D we have UDL. So to go to point E we have nothing, so we will draw a straight line. Okay, and then we have 2 kilonewton acting downward. So we went up 0.7. Now we have to go down 2 kilonewton in the form of inclined line or diagonal line. So what it would be? So obviously when we go down, it will be somewhere here, and the value would be 1.3 minus 1.3. So you can connect these points with the diagonal lines. So it's not a good diagonal. Okay, now once you are at point B, at point D, sorry, at point D, D to B we have no distance, nothing, so we will draw a straight line. Now we are at point B, so obviously this value is minus 1.3 as well. Once we are at point B, we have to go upwards 3.3 kilonewton because the reactions at RB is 3.3 kilonewtons. So we will go upward. So 1.3 we will cover in here, and then we will go straight up 2 meter up. So it will be 2 here, 2 kilonewton, sorry. Now once we get to point B, I mean we had total 3.5, 1.3 is in negative zone and 2 is at positive zone. Once we are in the positive zone with the 2 kilonewton, then we have a UDL load which is 2 kilonewton on our 1 meter span. So it will be 2 kilonewton in the form of inclined line or diagonal line at point C. That's how we can draw our shear force diagram for this type of beam. Okay, so this is our negative zone and this is positive zone. Okay, now we have to draw our bending moment diagram. In order to draw a bending moment diagram, we have to calculate bending moment, then we would be able to draw our bending moment diagram. Okay, bending moment at point A will be 0.7 multiplied by 0.7 multiplied by 0 equals to 0. Bending moment at point E, in order to get a correct bending moment diagram, I have to create some more points at our beam so we can get a correct bending moment diagram for this beam. Okay, at point E, 0.7 multiplied by 1. From A to E is 1 meter with having only one load at point A, which is upwards. So it will be 0.7 kilonewton. Bending moment at point D will be 0.7 multiplied by 2 minus 2 multiplied by 1 multiplied by 0.5. So the answer would be 1.4 minus 1 is equal to 0.4. Okay, 0.7 multiplied by 2, which is from A to D, minus 2 multiplied by 1. UDL always acts at the middle of its span, which is 0.5 here. So 2 multiplied by 1 multiplied by 0.5, and the answer is 0.4. Now bending moment at point B. Okay, so 0.7 multiplied by 3 minus 2 multiplied by 1 multiplied by 1.5 plus 3.3 multiplied by 0. Okay, so 0.7 multiplied by 3, then 2 multiplied by 1.5, then 3 multiplied by 0 because B has no arm, so that's why it will be 0. 2.1 minus 3 plus 0 is going to be minus 0.9. Okay, now bending moment at point C, which is final point, 0.7 multiplied by 4. From A to C is 4 meters, so that's why it's 4, minus 2 multiplied by 1 multiplied by 2.5. So 2 multiplied by 1. To get to point C, we have 2 meter and half, 2.5. Then we have one load at point B. At point B is going to be 3.3 multiplied by 1 because B to C is 1 meter. And then we have another load, UDL, last one, which is 2 multiplied by 1 multiplied by 0.5. UDL acts at its mid span. Okay, so how much it would be? 2.8 minus 5 plus 3.3 minus 1. At the end we will get 0.1, which is close to 0, so we'll consider it 0. Once we get 0 at our last end, it means our calculation is correct. Now we have to draw our bending moment diagram based on these values. So let me draw some points on it first. Okay, at point A we are 0. At point E we are 0.7. 0.7 is here somewhere. Okay, at point B we are minus 0.9. At point D we are 0.4, which is I consider is here, so it's just a roughly guess. Then at point B we have minus 0.9, so which is somewhere here, I would say. At point C we have 0. How we will connect our lines? From A to E it will be diagonal line. Okay, from E to D it will be a curved line, parabolic line. So I will draw something like that. from D to B, it will be again diagonal line. Okay, from B to C we have UDL, we will have again a curved line, a parabolic line. So that's how we can draw our bending moment diagram for this type of beam. Okay, so this is my negative zone and that's positive zone. That's it for today. Thank you for watching my video. Please don't forget to subscribe my channel.